Why is it named Sunset?
Oh, my first project that I was supposed to do with people but haven't done yet is a sunset. So
Oh,
that's
okay.
why the file was called sunset. But for you, we're not going to do that, unfortunately.
Okay.
Yeah.
Okay.
All right. Can you tell me what we did last time?
Oh, yeah. Uh, we learned how to uh, design function and data definitions in steps.
Very good. Okay. Um, One key idea from last time is also that with data definitions, when you write a function for that data definition, how the function will look will mirror how the data definition looks. For example, line 49 to line 55, the the idea of breaking down red, yellow, and green, that's very similar to the data, line 33 to line 37, right?
Yeah. Okay.
Okay, so I'm gonna give it so my goal right now is to give you all these small data small data types. I'll give you another
Okay.
one. So we call this enums enumeration because you can enumerate all the possibilities. Red, yellow, green, there are only three.
Yeah, that's
So I'll
right.
show you a more general one. So let's say, uh, I'm going to go to line 61. Let's say, here's a new situation. Let's say I'm the government and I'm calculating tax brackets for my citizens. Okay?
Okay.
So this is information. We have information and we want to encode that into data. So how do I do that? First, I write a data definition. A bracket is one of, let's say, zero. Do you know range notation? Like, if I write this, does this make sense?
Yeah.
So square brackets inclusive,
Yeah.
round brackets is
Act.
exclusive. Okay,
Yeah.
good,
Okay.
good. Okay, so it's one of so it's a number, and then 1,000 to let's say 5,000. I'm coming out of these numbers randomly, and then we have
Okay.
5,000 to 10. Okay, let's do this. 5,000 or more. So what's interesting about this is we can't use the data language feature like on line 33 because we're talking about ranges, right?
Yeah. Okay.
So this is similar to the previous one we studied in a sense that it's about listing one of many possibilities. Like you can't be in more than two text brackets. You can only be in one of them, right?
Right.
And but it's different in the sense that there's an infinite number of possibilities for where you're at. For example, I could be in the text bracket 0 to 1,000. Maybe my income is 500. Okay?
Yeah.
Oh,
Okay.
sorry, I should say text bracket income. Well, are you familiar with how taxes work?
No, not really.
Okay, no, sorry, so I shouldn't make assumptions. Let me explain to you how tax bracket works. So, depends on the country you live in. Also, I don't know if you pay taxes there, but you probably do. I don't know.
I
So
think the taxes are paid everywhere.
it's it's funny that you say that. Okay, no, I'll tell you later after the recording's done. Anyway,
Yeah.
um,
Okay.
so in some countries, the tax you pay is proportional to how much you make. So, for example,
Yeah.
let's say you make very little money, maybe you won't get taxed at all. Maybe
Okay.
you make some amount of money, you get taxed like maybe like 5%. If you make a lot of money, maybe you get taxed 10%, for example. Okay?
Okay.
So here we got three tax brackets. So if you make 0 to 1,000, maybe you don't get taxed. 1,000 to 5,000, you get taxed a bit more. 5,000 or more, you get taxed a lot of money. Okay?
Yeah.
Okay, so next I write the interpretation. So tax brackets based on income. So what does this mean to humans? So we got two. So I'm doing the first two steps of the design recipe. First, I have the data representation. How are we encoding this information? And next, we have the interpretation. What does it mean to a human? Next, I have some examples. Uh, so the thing about examples here is that there are many out possibilities. So for example, we might do lowest 500. What's very important is that you get an example at least from each text bracket, from each possibility. And then maybe this one is this. Okay, so I create some interesting examples. Notice I have one example that's a decimal, just to have some variety. It's
Okay.
also important to have edge cases. Have you heard the term edge cases before?
Yeah.
So it's values that are at the boundary of things, right? So like
Yeah.
5,000.
Yeah.
That's why the inclusive and exclusive is important. So maybe I have one
Mm.
also for the middle. Um, and then we have lowest. The zero is also an interesting edge case because it's the smallest possible value. Sorry, so I'm trying to figure out interesting cases here. Uh, okay. So this is the third step. The final step is I haven't covered that yet. I covered that later. I'm not going to write the functions for. Okay, I'll just give you a sample function. So let's say we have a function that's compute the hex percentage for the given hex bracket. Okay. For the given income.
Okay.
Okay. So first, this is the purpose statement. Next, I write the signature. So it's going to take in a text bracket income and it's going to produce a percentage. So I'm going to say it's a number. Okay. So notice how we have information, compute the text percentage for the given income, and I turn that into a signature data for the computer. So it's going to take in the text bracket income. So text percentage is information, but the computer is not going to know it's text percentage. It's going to know it's a number. So I say, oh, okay, number. Okay.
Okay.
So next I write the function. Let's say get text percentage. Text bracket income. Okay, I'm just going to say TBI just to keep it short.
Okay.
So this I've completed the first two steps and I wrote the stub. Next I write test cases. So I'll get text percentage. So you want to make sure you cover all the interesting test cases. So for example, lowest zero. Let's say I want the lowest text bracket to be no text. So let's say 0%. And let's
Okay.
say, yeah, so I'm going to, okay, wait, let me just paste all this. Okay, so I'm sort of like setting myself up for success because I've already enumerated all the interesting test cases, and so I just have to use them. So I'm using very little brain power right now. Okay,
Yeah. Okay.
so zero for lowest. For middle, let's say is I'm just going to come out with like 10%, so zero point 0.1. And then for let's say for highest, let's say it's 20%. Okay.
Okay.
So once I have the answer, now I can do my last step of the design recipe, which is to fill in the body. So the structure of the function is mirrors the structure of the data definition. We see the data definition is about making a choice between one of three possibilities. So I need a conditional. That's the language feature that allows me to distinguish between three cases.
Mm.
So I use if. So if TBI is at least zero and TBI is less than 1,000, but not including 1,000,
Yeah.
then I can do zero. Else, if it's at least 1,000, so normally I tell students to fill this in for me, but because I think you're more advanced, I'm just filling in yourself. But if you want to like do something on your own, let me know. I'll let you do it.
Yeah. Okay. I think that is like quite easy.
Okay.
Like definitely we won't have like negative income, so that case is not necessary. Yeah.
Dude, I forgot. I ran run and you have to add parentheses. I've completely forgot.
Oh.
So it's order of operations. Like in C++, it will know that it should do the less than before the and because of order of operations, but that doesn't exist in this language, so you have to be specific. So if I run again, it should be okay. Oh shit, it failed.
Yeah.
Oh, wait. Wait, am I stupid? Why did it fail? The test operator is failed for the test middle 1,000. You do not expect the evaluation officer to raise an exception. Did I make a
Why
typo?
is that? Why is that? Like, hmm.
Did I make a wait? Can you sanity check this? Did I make
Yeah,
a mistake?
you like here like in line 69 you said uh
Oh,
instead of 1,000 5,000.
thank you, thank you. Okay, so
Yeah.
yeah, I'm human too. I make mistakes.
Yeah, yeah. We all are, yeah.
Okay, so let's see. My highest 5,000. Oh, so I made another mistake, right? 79 should be less than equal to.
Yeah, yeah.
Yeah, okay, so now another mistake. Okay, now it's good. Okay, so actually, I did make I genuinely made those mistakes. I wasn't pretending, by the way. Sometimes I purposely
Okay.
pretend to like prove a point, but I actually made those mistakes. But this shows the importance of testing. Like
Yeah.
I was like so confident, like, oh, this is so easy. But I made a mistake, and this is why it's important to do tests and to do edge cases, because edge cases is where you normally mess up. Like that
Yeah,
5,000, if I
okay.
didn't write the test, I would have let that pass. And people and like imagine if this I wrote code for a real government system, people that made exactly on the edge case would be paying less taxes, and the government would be losing money, and I will get fired, right?
Yeah,
Okay,
it's
okay. I
quite
don't know if you plan to work for the government, but yeah, I'm just letting you know. Okay,
I don't think I will, but
okay. Well, okay, yeah. Just regardless of where you work, you need to make sure that you test everything. Okay, so that's a different idea. So we call this intervals. This data type, this data representation intervals because well, it's intervals.
yeah, okay.
Um, I'm not gonna show you this, but I'll show you a little bit. I'm not gonna go too much into it. Online in 890, I will show you a new data representation. So let's say we have grades. Let's say we have like uh 90 to 90 to 100. I think this is a pretty common thing. And then okay, but I think it's a bit extreme. So let's say you have three possibilities. You have like 90 to 100, 80 to 90, and then they don't even give you a number. They just say fail, right?
Yeah, okay.
So this is a mix of intervals and enumeration. You have like
Oh,
some values that are not that are just finite, like f, and you have some values that could be anything, right?
right.
So we call this itemization. So I'll give this names for your reference. So here we call this itemization. But same principle. The difference between these three isn't really that important. Is it's more like for teaching. When you teach someone, I show them one at a time. I first show them enumeration, then I show them intervals, and then I show them itemization. But the principle is the same. You're distinguishing between one or more cases. The data's definition, you'll see like it's one off, and then you show the different cases. And then the function distinguishes between each of those cases, and they should look the same. Okay?
Okay.
All right. There's one last idea I want to show you before we move on. So I'm going to go back to line 59. Do you remember the traffic light?
Yeah.
So I'm going to do a thing called get duration. So traffic lights, they have timing, right? Like a green light maybe for 30 seconds, red for 60 seconds, for
Yeah,
example.
okay.
So so okay, just to show you good habits. So it's going to take in a traffic light and it's going to produce a number, like so it gets how long the light should stay for each light. So let's say get duration for red is, let's say, 30 seconds. Oh, rule of thumb, whenever you have a number, it's good to specify the unit of measurement. So for example, I might say in seconds, right?
Okay.
So again, the computer doesn't know that it's in seconds. The computer just sees number, but as a human being, I say it's in seconds. So that goes into the purpose statement.
Okay.
So 30 seconds. Again, you're doing competitive programming, so you technically don't need to know that, but it's a good thing to know. So it's say yellow is very short, maybe 3 seconds. And green, let's say it's let's say 10 seconds. Okay.
Okay.
So now again I can do this. I think you've seen this before. You write the cases to distinguish between the many cases. Red, I already know it's going to be 30. Yellow, I already know it's going to be 3. And then green is going to be, what did I write? Is it 10? 10. All right. So let's run it. Let's see if I made another mistake. Okay, looks good so far, right?
Yeah.
Okay, now new idea. Now this one is important. Now, okay, you can start focusing again. I know you're like half focused just now, but now you really must focus. This is important.
Okay. I will. I will.
Okay, line 49 to line 73. There are two functions, right?
Yeah.
Don't you think they look kind of the same?
Yeah. Almost identical.
Okay, what are the differences?
One returns like a string and one returns a number.
Okay. Oh, actually, the first one is not a string. It's a
Uh,
light. It's our light
yeah,
data.
sorry, it's a light.
Yeah,
Okay.
our traffic light data type. Okay, no, the point is the results are different, right? That's the only difference.
Yeah, okay.
Okay, theoretical question for you. If I write another function for traffic light, is it going to have the same differences and the same similarities?
Mm, yeah, like it must because we only have three states.
Okay, so there's the fourth step of the design recipe that for data definitions that I haven't explained yet. I'm going to explain it now. This last step is called the template. So first,
Okay.
I'm going to go to line 40 now. Line 40, right below the traffic light data definition. I write function. I'm going to write light template. The name doesn't matter. And then I'm going to write light.
Okay.
I'm going to take the body of rotate between lights. I'm going to copy the body. I'm literally going to paste it. I'm going to replace all the outcomes with dots. And then I'm going to end the function. This is the template. Okay?
Okay.
Now, it might not seem important, but this is very important. What is the template? The template is what lets you go from data definition to function. Okay?
Okay.
Remember how I said that the structure of the function will mirror the structure of the data definition?
Yeah.
The template is a manifestation of that. Okay?
Oh, okay.
So in theory, if I want to create a new function for traffic light, for example, well, I don't know, like, I don't know, what else can we do with traffic lights?
Ah,
Let's say, let's say we want to have audible sound cues for, let's say some people are blind. Okay, this is a stupid example, I guess. You wouldn't be driving if you're blind. Okay, let's say we want our traffic lights to have sound cues. Oh, let's say what
okay.
pedestrian traffic lights. Pedestrian traffic light, you might have sound cues, right? Like when it's red, you'll say stop, stop walking, right?
Yeah.
It's a bit contrived example, I admit, but okay, I'm gonna create a new function below light template. So I'm on line 48 now. I'm gonna literally paste the template. Next, I'm going to write the purpose statement. Produces words to say on a given light state. Next, I write the signature, so traffic light. So it takes in a traffic light, it produces a string. Oh, I'm going to go back to line 38. One thing that you can do, some people do it, some people don't. I think it's a good habit to do it. You can also write the signature of the template, but we don't know what it produces, so we write question mark for the resulting type output. See
Okay.
that on line 40?
Yeah.
So you can do that also, or you cannot, it's up to you. Uh, okay, anyway, back to the template. So yeah, when I now I just write where, and then light. Oh, so I have to replace the name. It's no longer going to be called light template. It's going to be called, let's say, like word word light. I don't know. It's word light. Yeah, I'm just going to call it word light. It's not a good name, but you understand, right? Word light.
Yeah.
Word light is rate is stop. Word light for yellow is slow down. Word light for green is go. And then now I can literally copy and paste my answers for here. Okay. All right. So trap. So that's what like I'm going to show you one more example. just to hammer home the point. I'm going to go to text bracket. So let's go to line 104. Okay, no, no, sorry, 111.
Okay.
111. So I'm going to write a template again. So like TBI template takes in the TBI. So the signature is that it takes in the text bracket income and it produces a question mark. That's it. It's going to end. Next, we need to distinguish between the many cases. But we replace the out results with dot dot dot. And that's it. If I hit run now, I think it should be okay. Yeah.
Okay.
Okay. So um sometimes I don't write the template, but when I'm writing a function, I have the template in my brain. This idea that the data definition has a certain structure and my function will have that structure is very important. Right
Okay.
now, it does okay, right now, because our problems are small and easy, it might seem like why do I need it? But imagine we go to research, we go to recursive structures, we go to
Yeah.
graphs and trees, like this will become important.
Like it will make sense. It will make sense then. Yeah.
Yeah. Okay.
Yeah.
All right. I'm gonna show. So right now, I wouldn't consider this the interesting stuff. Right now, I'm just showing you the basics, which I think it's still too easy, but at least I'm showing you the steps. I'm going to show you a different data representation now. And the next I'm going to show you is composite structure. So I'm on line 173 now. I'm going to show you something new. Um, what does composite mean?
Like I don't really know. I don't know that word.
Oh,
Uh,
okay, fair.
I can Google it if you want.
Sure. Yeah, sure. Humor me. What does composite mean?
Okay. Okay. Uh, that like it's like made out of uh, some smaller data. Yeah.
Yes. So it's made of smaller pieces.
Yeah.
Let me give some examples. Let me hold on. Let me find this. Give me 1 second. Let's see. Yeah, I think that's good. So let's say this is from the textbook. I'm going to take this example. Uh, what are some examples of like composite inform? So like you create composite data when you have composite information. That's information that is grouped together conceptually. Here's an example. You know, uh, let's say a phone. Let's say your phone. Our phone, we have a context. What is a contact? You have the person's first name, their phone number, maybe their email. You know what I'm talking about?
Yeah. Yeah. Okay.
Okay, another example. Let's say songs. If you go to Spotify, a song, it has the name of the singer, the name of the song, the date in which it was released, right?
Yeah.
The publisher, all that. So all of these are composite information.
Yes.
Uh, I'm going to use a song example because that's what's used in the textbook I base my sessions on. So let's say, yeah, we have this information. So we have information here, which is that uh, the song's name, singer's name, and the year it was produced. Okay.
Okay.
Next is the data representation. How do we represent this in our language? So we have a language feature for this in this language called data. So I write data. Okay. Then I write the name of the data. Next,
Yeah.
I do the fields. Okay. That's it. So this is how I write the data representation for iTunes song. I don't know who uses iTunes now, but this textbook uses the example iTunes, so I'm using that.
Okay. I don't
Uh,
even know what is iTunes.
oh my God. Oh, that's funny.
Yeah.
Okay. So this is the first two. What's the next step of the design recipe?
Mm, interpretation, and the next is examples. Yeah, examples, of course.
Examples. Yes, very good. So I'll give you some examples here. Uh, actually, no. Okay, no. What songs do you listen to? Can you give me examples?
Oh my God, I don't listen to like English songs. Uh,
Uh, Okay, for the sake of time, because I don't know how to write in Polish, so
Yeah.
I'm gonna give you some songs. Yeah, have you heard of La Vie en Rose?
No. Okay.
I'm gonna send it to you later, man. Dude, you gotta
Yeah,
listen to
of
that,
course.
man.
Of
I no,
course.
I think you know the song. If you listen to it, you'll know what it is.
Okay.
It's
I
famous.
I only listen to like Kendrick and Kanye.
Oh, oh, you know Marvin's Room?
Yeah.
Okay, that's Marvin's Room. Uh, it's Drake. It's Drake, right?
Yeah.
I don't know when it was made, but let's say it was made in 2005. I don't know when it was
Okay.
actually made. Okay, so I'll do this for now. Um, okay, what's the next step after examples?
Uh, like actually writing the code or the
Template.
template. Yeah.
Okay, so here's the interesting about template. It's the code version of the. Okay, I don't know if you noticed, there's actually a relationship between the functions and the data, the design recipe. So
Yeah.
okay,
Okay.
let me pull up the drawing board. I'm still on the mouse, so it's gonna look like shit, but
Yeah,
it will
that
hopefully
is no
work.
problem for me.
Okay, you see my screen?
Yeah.
Okay, I was doing Pythagoras theorem with someone just
Yeah.
now, so
I
you
can
see
see
this.
that. I can see that.
Yeah, but I didn't give you that problem because I think you're a little bit more advanced, so we skip that. Okay. Um, so we have D for data definitions, F for functions. So the first step for data definition is the data representation, right?
Yeah.
For function, the first step is signature. Oh yeah, I think they have a text feature actually.
Yeah.
Oh thank God. Okay. The data we have after that we have interpretation. And then for the function we have what is next for a function?
Uh, examples also, like testing.
That's the
No
next one.
template.
What comes before the testing?
The stop.
Oh yeah, that too. But what comes before the stub?
What? Uh, like also like the interpretation
Yes.
of okay of what
Well,
is coming in and what is coming out.
yes. But we
Okay.
call this the purpose statement.
Yeah. Okay.
Uh, okay. Data. What's after interpretation?
No, so examples. Yeah.
Okay, I wrote the E by accident, so I give you a hint.
Yeah. Yeah.
Okay. What's after purpose statement functions?
The stop and then examples. Yeah.
Okay. Examples and tests, right?
Yeah. Okay.
Okay. What's the last step for the D?
Uh, like the actual code and for the function is template.
It's actually other way around. It's template for the data, but
Okay.
function is
Sorry.
code. No, no, all good.
Sorry.
All good, all good. And fill it, actual, like I call this like fill in body.
Okay.
Okay. I don't know if you realize there's a relationship between each step, right?
Okay.
You see that?
Yeah. Okay. So the data comes first. Yeah.
First step is for the computer. How do we get the computer to understand our data definition? How do we get the computer to understand our function? So the computer sees it in terms of signature, inputs and outputs. Okay. Interpretation and purpose statement. Both of them is for letting the human being understand what's happening. Both of them is about information. Do you
Okay.
remember how I said that the computer science is all about the exchange between information and data? Do you remember that?
Yeah.
So, um, yeah, so this is like the foundations for everything that we do in our sessions. These first two steps of each data and function is responsible for this idea. These first two steps. See that?
Yeah. Okay.
Okay. These examples and tests, in some ways, they are like they build confidence that what we're doing is correct. Like, if we have a data but we cannot create examples, there's something wrong with our data. If we literally cannot create it.
Yeah.
Right now, we are able to easily create our examples because our data is simple. Once we move on to more complicated things like trees and graphs, there will be data we cannot create because there's some our definitions are not well formed mathematically. So we'll get to that in the future. But in some sense, examples are a form of test for data. They are testing that our data can exist. Okay?
Okay.
Examples that are test, okay, this one is for functions. Obviously, they're testing the function, right? Input and output.
Yeah.
So these two, in some sense, they're like proof of concept. They're testing things. Okay?
Okay.
Template and fill in the body. I don't know if you noticed, they're yin and yang. You know yin and yang?
Yeah.
They're two complements of the same idea. Template has no substance but gives you structure, right?
Yeah.
Okay, I'm gonna draw the yin. That looks like shit, but and then this is yang.
And the feeling body is the opposite, yeah.
Yeah, filling body is the actual substance. Template's the structure. Filling body is the substance. Remember how I said there's a secret step, which is the stub?
Yeah.
There's a secret step. Actually, I was lying a bit. It's not a secret step. It's actually the fourth step of the D. The template is the secret step. I didn't want to
Okay.
introduce the template, so I said it's a secret step. It's not. It's actually not secret. It's actually not part of the function. It's actually the template. The stub is the template. Okay.
Okay.
Yeah. So this final thing is about substance, structure and form and structure. So this is the foundations of every. Literally, I'm not even kidding. It's the foundations of everything we do as programmers. It's so important. Okay, so like burn this into your brain. It's very important.
Yeah, I will watch this in YouTube again.
Okay.
Yeah.
All right. This session is gonna expire, so I have to close this one and send you a new Zoom link
Yeah,
on
of course.
Gmail. Okay, so I'll catch you in a minute, all right?
Yeah. See you soon. It's not necessary, okay?
Okay, there you go. Okay. All right. So back to where we were at. So where were we at? I was summarizing the design recipe.
Yeah.
Um, okay, so we're working on iTunes song. So the last step of the design recipe for data is the template. Oh, by the way, sometimes you might do the order differently. When you're learning, I suggest you follow the order from data to function, step one to step eight. But you may mix them around in the future, and that's fine. Okay,
Okay.
back to this. So iTunes song, it takes an iTunes song, and then it produces, we don't know, it's a template. So I'm going to call this ITS, iTunes song template. Takes in an ITS. Let's call it ITS. Uh, so for the template, okay, it's a bit funny. Let me see how. Let me look at the textbook. I have a way of doing it, but it might be different from the textbook. Let me see.
Okay.
Hmm. I don't like that. Yeah. Okay. So I have a way of writing this, but yeah. Okay. So first I write dot dot dot, and what can I do with ITS? So let me say, like, we have an ITS right now, iTunes song. What can we do with it?
We can like uh I don't know, print out the author or the name.
Okay. Yeah. So more fundamentally, it's not even about printing out. It's about getting
Like
uh,
yeah. Okay, sorry.
yeah.
My bad.
No. You're correct. It's getting the individual information of this big structure. So composite data structure, it has a lot of pieces. We can get the pieces, right? So we can do
Yeah.
name, singer, and we can do dot year. Yeah. So I'm not everyone likes to write it like this. Why do I do dot 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 between each of the fields? It's because it's sort of like tell the people who's using this template you might write code between these things. Okay.
Okay.
So I like to do it like this. Sometimes you might see people write it on new line like this. Like this. I don't like this. I prefer to. I mean, if it's really long, I might do this, but I generally like to keep it all on one line. Um,
Okay.
That is basically the template. One more thing I got to talk about this idea of creating a structure. When you do this, right, you're doing three things. So for composite structure, when you create a structure, you do three things first. You create two names. Okay, technically you create a name, but normally you create a name, but in this case we create two names. One name is the type, and one name is the how do I call it? Like the actual like word to use to create the thing. I don't know how to. For example, the type of this is iTunes song, but when I actually want to create iTunes song, I use the word song, like on line 183. You see that?
Yeah, okay.
In most of the time, they're actually the same. Like in C++, when you create a new class or new struct, that's type and the word you use to create the thing, they're the same.
Yeah, yeah.
So in our case, there's actually two. You can ignore that. It's not super important. Okay, next, you can when you create a structured data, you can break it down. No, I should say you can create it by gluing together smaller pieces. So we call this construction.
Okay,
Last thing, you can break it down. So we call this elimination. So you hear the terms construction and elimination. You don't have to know those words. In fact, no one ever uses them unless you're in very specific circles.
I don't
Uh,
think so.
yeah, it's okay. You don't have to know the name,
Yeah,
but you just have to know these
okay,
three concepts. The idea here is that when you have structured data, you can you have a name, you can create it, you can construct it, and you can break it down. Every
okay.
language will allow you to do this differently. For example, like in C++, there is the dot notation, so the idea like it's the name. But in C++, if it's a pointer, you do the arrow notation, right?
Yeah,
So that's a
okay,
form of
yeah,
elimination. Yeah.
okay.
Okay. So that's it for data. So for function is exactly the same thing. I'm not going to show it, but I will show the how you use the template, how it looks like. So it basically looks like this. You have the template. So let's say we want to, okay, very simple. I'm just going to say it's going to get displayed. So like if on Spotify or something you want to show like what it looks like on display, uh, I'm going to skip all the steps. I just want to show you this how to use the template. So you get the name. For example, let's say my display I want to do like name and then a dash and then singer, and then I do dash the year it was made. Okay.
Okay.
So see how I use the template there?
Yeah.
I copied it and I replaced the dot dot dots with actual substance, right?
Mm.
I skip the rest of sign recipe just to show how template is used. Okay, this is a note to yourself if you see me why I skipped the design recipe.
Okay,
Okay,
okay.
I think we've covered all the basic stuff. We're now going to move on to something more interesting that's actually going to test your brain. But before we do that, do you have any questions?
Yeah, I don't like getting to the next part.
You don't like it? Oh man,
Yeah.
we're actually going to go to stuff you can actually use in your competitive programming now.
Yeah, I'm
Uh,
just kidding.
okay,
That's why I'm here, really. Yeah.
okay, good, good, good. Let's see. Okay, so okay, now we're actually this is actually going to get difficult. No, okay, not difficult, but like more challenging. Theoretically, given what we learned so far, notice how all this thing we have so far, they the data they hold, it's finite. No, it's not finite. No, finite is not the word. It's not arbitrarily large. That's like a fixed size, right?
Yeah.
You get what I'm saying?
Yeah.
Like they're not a list. You know, like a list you can always add stuff to it, but
Yeah, yeah.
this like iTunes song, red, green, yellow, they're all
It's like
fixed.
fixed size. Yeah.
Everything we've done so far, we call it fixed size data. We are now going to move on to arbitrarily large data. And this is where we
Mm.
come into data structures. Okay?
Okay.
A lot of time data structures allow you to have arbitrarily large data. That's what makes them interesting.
Okay.
In theory, based on everything you've learned so far, what's the simplest arbitrarily large data definition we could make?
Like a list.
For example, what's the simplest list we could define?
Uh, like a list of numbers
Good. Okay. How do we define a list of numbers?
in this language.
Yes.
Oh, mm, s- uh, okay, so we use the keyword data, I
Okay.
think.
Actually, I want you to
Then
write it. We're on line 202. Can
okay,
you write it for
okay.
me?
Uh, here or where? What line?
202.
Okay. Uh, like the name of the array, like or list. Yeah,
Okay.
I can call it just list. Uh, okay, and like the thing that we'll call it. Yeah, like
Okay.
the instance. Yeah, of the
Okay.
uh, why song. Like, mm, uh, we can also call it list.
Okay. For our sake, I'm gonna call the list capital L for the
Okay,
type.
okay,
Yeah, and that
okay.
one is lowercase. Yeah.
Uh, and can I give it like only one parameter
Sure.
or
We say one
okay,
field. Yeah.
one field, okay. And that is
Oh,
it.
okay, but this is not
But
arbitrarily large, right? This only holds one number.
okay. So
What if I want to
it's
hold
not.
up another number?
Oh, okay. Wait a minute, wait a minute. The data structure here is like weird for me
Why do you say that?
because uh, I don't know how to make like multiple what did you say? Not parameters, but uh, in the parentheses, what is
The
that called?
fields?
Fields, yeah. Hmm. Yeah, I don't think I can figure it out.
Okay, I'll tell you on the right track. But is it possible for there to only be one field in our structure?
No, okay.
So there needs to be a second thing, right? If it's one thing, it's game over. If it's one thing, we can only hold one thing. We need a second thing. What's the second thing?
Like a different number, but mm, it's not it.
Now I can
We
hold two
can,
numbers,
yeah, but uh,
but I want to hold as an
as many
arbitrarily
as, yeah.
large amount of numbers.
Is it possible to do with all that I have learned?
Yes,
Okay, it's quite interesting.
yes. I told you it's more challenging now. Okay, I'll let you think about this. I need to get some water. I'll be back in like 2 minutes.
Okay. What? Uh, uh, I can't use like, hmm. Uh, okay.
All right, I'm back.
I haven't figured it out. Okay.
It's not simple, I'll tell you that.
Isn't, yeah. Ah,
Okay. I'm going to change the names a bit. I'm going to say it's num list instead of
okay.
just. I'm going to add the word num just to make it more specific. Okay. I'm going to give you a hint.
Yeah.
So we have one. So num list has two things. It has one number, but we know we need a second thing because if we only have one thing, that's just one number. We need a second thing. The second thing cannot be a number because we only have two numbers. Okay.
Okay.
What else could a second thing be? What are options here?
Like a data
Okay,
structure.
what could go in there? What data?
What? Like a list,
Oh, what list?
like
List of
the one
what?
that of numbers.
A list of numbers. Okay, can you write that down?
So like the same that we have created.
Ah,
Okay,
okay. Very good.
but okay,
Okay, good. Uh, so these are fields. So fields are just like parameters to a function. You don't have to write opening parentheses there. It's just num list. That's it.
okay.
Okay, so can you tell me the idea of this? Like, why is it that you said that the second should be a num list?
Because like the structured num list uh, holds like one number, and we can call it again to hold another, and so on.
Okay, very good. You know, like Russian doll. You know Russian dolls?
Russian dolls,
You know what I'm talking about?
like the one that opens itself and it creates like the smaller ones.
Yes, yes.
Yeah, okay, I know them.
It's like that, right?
Yeah,
Okay. Um, okay, so great. We have done the first two steps. Okay, I'm going to delete the opening parentheses there. So it's just this,
okay,
right?
okay, okay,
But I'm going to change the name of the second num list. I'm going to call it rest because if I call it num list, we have a naming conflict, right?
okay.
So I'm just going to call it rest. Um, so like rest of the numbers. Okay, we have done the first two steps of the design recipe for data. What's next?
Uh, like examples.
Okay, yeah, let's write some examples.
Okay, so I don't know, like just a simple array.
Yeah, but I want you to define it. Use like actually make a variable and use num list.
Oh, okay, okay, okay. Sorry, sorry.
Yeah, all good.
So uh, like we can call it okay. Is that
Okay.
uh? So it will be mm, and can I hear like uh write how many I want, how much I want, so,
Yes.
or
Yeah. As
really?
many numbers as you want.
So
Oh,
I
but
can
not
do
like
it
this,
like that.
right? No, not like if you look at the numbers definition, it only takes in two fields, right? So you can
Oh,
only
okay. Sorry,
yeah,
sorry. So
yeah.
it will be
Yeah?
like this.
Yes, yes, exactly. Yeah.
Okay, it's
Okay.
quite funny.
Yeah.
It makes sense. Okay, okay.
Yeah.
Yeah. Mm. And we
Oh
have to
shit.
do like two more. Yeah. Is that okay?
Well, num list must take in two things, right?
Yeah.
So that
Oh,
three,
okay. Sorry, sorry.
yeah,
Oh,
that's all good. So it needs another num
uh,
list. Now we can put four there. The second thing must be a num list,
namely, okay.
right?
So how do we do like the last one?
Good question. How do we do the last one?
Like we need to like create a empty list or something?
How do we create an empty list?
Uh, that is good. Do we have to change like our data structure?
Yes, we cannot create an empty list, can we?
No, I don't think so.
Yes, and because we cannot create an empty list, we can't even create an example, right?
So it will be like, oh, sorry. Uh, I hate the, okay, so I might write it down. Like empty.
Yes, very good. Now can you create
Okay.
example? Yeah, now can you create the examples?
Is uh is that okay? No, no, no. Yeah.
Yeah, but yes, that's correct. Yeah.
Okay.
Okay. Let's pause here. We are running out of time. There's actually one thing I forgot to tell you about. Um,
Okay.
I you also need to write the types for the um
Oh, okay.
the data structure. So can we go to line 184?
Yeah.
So normally I would tell people to write like a song is a song of string, string, number. You see that?
Yeah.
There's another way of writing this. We can do a type annotation like this.
Okay. Okay.
Uh, because yeah, right now like we don't like if I didn't do this, we don't know is like name a string, is it a number? But now we know, right?
Yeah, yeah, okay.
So same thing for a num list.
Okay.
I can also I can also say num is a number and rest is a num list.
Okay.
Yeah. So yeah, so like we have information, right? We know it's a list of numbers, but the computer doesn't know that. So we tell it, oh,
Mm,
a num is a list of numbers, right? Data representation.
okay.
Yeah, yeah, okay. If I run it, it should be okay. Oh,
Uh,
wait, what's that? Oh, oops, typo. Ah, empty. If I run it now, the empty we use it's a default name in the language.
really, really.
So
Oh,
okay, I'm gonna say okay. This is a bit of a cheat. I'm gonna say like two letters MT. Okay.
okay. Why is that?
Why is the Why is the what?
Why is it called empty?
Like two letters MT?
Yeah.
Because MT like ENTTY is
Empty.
taken.
Okay. Sorry, sorry,
Yeah.
sorry.
You,
I'm not like native.
you,
Sorry.
oh no, I'll go away. But you see right, letter M and letter T, so it sounds like empty.
Yeah, yeah. Okay,
Yeah, yeah.
okay.
So it's a bit of a cheat. Yeah.
Yeah, I get it now. Okay.
Okay, so let's pause here.
Okay.
So but you just experienced it, right? But you could not create an example, so the data definition was faulty, right? It was not well
Yeah.
formed. So
Okay.
what we just introduced is we re introduced a recursive data definition, a data definition that refers to itself, right?
Right?
Because we see numlist is defined by numlist, okay?
Okay.
Like the rest is numlist. An important thing about of recursion is that there's a base case. If you do not have a base case, it will go on forever. In the case of examples, you cannot even
Right.
create the example. You've just experienced it. All right.
Oh my God.
All right, before we end, what's one thing that you learned today that stuck with you?
Uh, not if we have a faulty like data representation, we cannot create examples.
Very good. Okay, I do have to run on
Okay.
for my next student. I'm glad you learned
Yeah.
something today, and I hope I
So
see you again.
like see you next week. Yeah.
All right, see you, man. Bye bye.
Bye.